OpenClaw is just like unhinged. We told our employees they cannot install OpenClaw on their company laptops. There's just massive kind of like security risk. OpenAI is never going to release anything like that. They can't release anything like that. But like that's what makes OpenClaw OpenClaw. If you don't do that, you also can't have an OpenClaw. A lot of things in the space are basically about catching lightning in a bottle. Early days of LangChain were me just building the library and tweeting about it. And I think that's what ClaudeBot did back in the day. Everyone on AI is on Twitter, it seems. And so if you just launch cool stuff and talk about it on Twitter, people will see and take notice. And that's a major kind of like distribution channel. There's so many wacky ideas of what you could do. OpenAI is never going to come up with all of them. Anthropic's never going to come up with all of them. We kind of need these random hackers. Just like go try things and see what happens.
This is VentureBeat's Beyond the Pilot, Enterprise AI in Action. I'm Sam Ridavine.
I'm Matt Marshall.
Today's episode is presented by Outshift by Cisco, Cisco's emerging tech incubation engine and driver of agentic AI, quantum, next-gen infra, and beyond. Today we're talking with Harrison Chase, co-founder and CEO of LangChain, one of the companies that arguably has kickstarted the AI agents era. What began as sort of like an open source framework for chaining LLM calls has evolved into now a full platform spanning LangGraph, deep agents, LangChain itself, and even an observability layer with LangSmith. What makes this conversation really timely today is this debate in the sort of heart of every enterprise AI strategy. As models get smarter, does the scaffold around them matter more or less? Harrison, welcome to the pod.
Thank you for having me. Excited to be here.
So it's about 2.5 years ago that you and I were sitting in a bar kind of near your office. Can we start off just sort of telling listeners about how LangChain started, perhaps a bit about your personal background, and then sort of those early days of what you guys were thinking with LLMs? What was the sort of thinking around that then created LangChain as a company?
Yeah. So my background's in machine learning and computer science. And so studied stats and CS in college, then worked at a fintech company, doing some machine learning stuff there. Then worked at an ML ops company where we did kind of like testing and validation of machine learning models. And that ties into some of the stuff that influenced what we built at LangChain. But TLDR, I was there at that company. I knew I was going to leave. I didn't know what I was going to do next. Told the CEO he wanted me to stick around for a few months. Said, great. In the meantime, started talking to a few folks, and this was like summer, early fall of 2022. So this was actually right after the stable diffusion kind of like moments. And so image gen was kind of like the thing that was really hot then. But when talking to folks, I noticed that a few other people were doing things with LLMs and very early versions of LLMs, the Da Vinci models from OpenAI mostly. But they were doing really cool things. They were doing like early versions of RAG and early versions of chat with SQL databases. Thought it would be really cool to kind of just abstract out some patterns because I noticed like common things that people were doing in terms of creating these. So abstracted those out, put those in LangChain, an open source Python package. Tweeted about it, and it got some good reaction. I was having fun, so I kept on tweeting about it and kept on adding more to it. And a month later, ChatGPT comes out. So LangChain was published the first version about a month before ChatGPT. Really good timing. ChatGPT comes out, and everyone's basically like, I want this, but for my data, for my stuff. And that's really the core idea of LangChain is LLMs are great. But we think they're way more powerful when they're connected to other sources of data and computation and using those to reason and then do things as well. And so these things that we call agents, we had those in LangChain from before kind of like from before ChatGPT launched. And it was based off of very early React papers and some very early kind of like academic research, not from us, from other great people out in the field. And the core idea was always about doing things with LLMs and connecting them and using them to reason and harnessing that reasoning ability. A few months later, we started LangChain officially as a company, really focused on that idea of connecting LLMs to other things. And I think a few of the things that we realized early on were that pretty much everyone would want this for their applications in some form and have some version of ChatGPT for their stuff. It was still ambiguous, like what that looked like exactly. Would it be chat? Would it be some other interface? How would they get connected? There was a lot of open question marks, but people wanted that. And so we thought there was going to be a lot of different agents out there. And we still do. We think there'll be a lot of different agents out there. And we think it's quite hard to create agents that work reliably. And this has been a consistent theme over the past 3 or so years of LangChain is it's hard. It's easy to get a prototype of an agent, something that you can tweet out, get a nice little Twitter demo of, but it's really hard to get that to be production ready. And that's where we've been focused as a company, is on bridging that gap.
You mentioned a lot of things there that we'll come back to, I think, in multiple questions. But one of the things that I always admired you and LangChain about at the start is literally papers would come out, and within a couple of days, you guys were implementing different forms of prompting strategies, different forms of chaining. And I think that also caused a lot of headaches for you later on when you had to sort of refactor things and put things together. We're recording this just as it's been announced that sort of OpenClaw is being either sort of acqui-hired or acquired or whatever by OpenAI. And people have really gone nuts for this agent, right? In many ways. You and I have seen that this is not the first one like this. You know, if we think back, we saw things like AutoGPT, we saw Baby AGI, all these sorts of really early kinds of things. Can you tell us a little bit about, what's changed? Like, obviously the models have gotten smarter, but it does seem to me that the harnesses and the whole sort of area and just the general thinking has sort of changed.
Yeah, I think a big part is the model is getting smarter. And then the second big part is the harnesses evolving around the model. And so what I mean by that is, if we think about AutoGPT, which at the time was the fastest growing GitHub project ever, I think, that was basically the same core architecture as OpenClaw. It's a model running in a loop calling tools. I don't hear a lot of people talking about AutoGPT anymore, and so I think it's fair, and no slight to them, but I think it's fair to ask, like, why is OpenClaw working? And it's still early, so we'll see what working really means. But why is OpenClaw working where AutoGPT didn't? And I think there's two reasons. One is the models. The models have just gotten better. Like, this idea of running an LLM in a loop and calling tools sounds really simple, but simple things are great, and it's actually hard to do that reliably. And so we can talk about the evolution of harnesses, but for a while, like, a lot of harnesses was actually putting more constraints around the model and not just letting it run in a loop and call things. Because we tried that with AutoGPT, it didn't work. Okay, let's do some other things. But now the models are actually working, and so you can do this simple thing. There's also been changes to the harness around it. And this basically, you can think of it as figuring out how to construct the environment in such a way that this model can interact with it the best as it's running in a loop. And so a really simple example of this is coding agents have been the hottest vertical for AI agents. Part of that is because they have a really good environment for the model to interact with. They have a file system. Models are really good at interacting with file systems. That also lets the model control its own context because it can read to and write files as needed. All the harnesses that we see for these agents these days, they all have some aspect of a file system built in, and they all have kind of like read and write tools and handle that in different ways. And they use the file system to handle like really large tool calls, or to offload kind of like history to when it gets too long. And so for a while, the models were below the threshold of usefulness, where you just couldn't run them in a loop. And so we were doing other things, and we're doing things like LangGraph, and we're doing things like writing chains and stuff like that. And then the models got better. And then after this point, you could run them in the loop, and they keep on getting better. But what we also see is that around that time, you can actually start making improvements to the harness. Because before the models were at that level, you couldn't really make improvements to the harness because you couldn't actually run the model in a harness. But then you could start running the model in the harness, and you start seeing all these different tips and tricks. And, we have our own harness of our own, and we have a page of everything that it does. And there's like 12 or 13 different kind of like high level things that it does. All of these were added like incrementally over time. And so I think basically we've gotten to a point where the models have continued to get good, and the harnesses we've started to do harness engineering and made progress there. And both of these things are starting to work in unison. And now this idea of like a long running, more autonomous assistant is more viable. And that's kind of what we see with OpenClaw.
Harrison, great to meet you. I've finally been following you. It's just been great to see the trajectory that LangChain's on. It seems like over the last 3 months or so, we've hit a new level. I don't know if it's just hype in these, Silicon Valley insider set, but it feels more than that, right? With Claude Code and OpenClaw specifically, obviously, Codex, it could be mentioned there, the latest Opus models. But what do these latest instances of agents say about the state of this technology right now? Is it for you just kind of a continuation of a trajectory, or has there been a step change?
I do think there has been a step change recently, but I'd say around 9 months ago, it kind of started, and it's been kind of, increasing sense that, and the step change really is just the ability to run the LLM in a loop and have it call tools and be useful. There's fewer graphs, there's fewer change, and there's more just let the LLM run in a loop. And I think like early versions of, there was some Sonnet model like that launched with Claude Code when that launched, and that was when it really started doing this. I would say with some of the Opus stuff, and Codex is a very good model as well. GPT-5.2 Codex, very good model. It did start probably to get better at longer term kind of like planning, if that's one thing. So I think there's a few different step functions. I think it probably happened a little bit before kind of like November. I feel like November, December is when it really kind of like caught on. I think part of that is because everyone went on holiday and then started playing around with these things and discovered how good it finally had gotten. But I would say over the summer was when we started investing in like this new style of harnesses. And so I don't know, I'd say it's like a combination of both. It is a step function change, but I don't think it happened like in a single night or with a single model release. I think it's been incrementally happening probably since the launch of Claude Code.
LangChain was your first thing. Then you had LangGraph. You talked about last summer you started working with stuff. I'm guessing you're talking about deep agents, right?
Yep.
Here. Can you break down what is a deep agent? What are the key components of it? Like, I think sort of I know what you're talking about, but for our listeners, I think this is a fundamental thing because these are things that have shown up. I think pretty much all the parts of OpenClaw are parts of things that are deep agents. So could
Yeah.
you walk us through that?
The core idea of deep agents came from looking at Claude Code, from looking at deep research style things. So OpenAI had a deep research, Google had a deep research, and from looking at Manus, and basically realizing that they were all doing the same thing under the hood. They were running in a loop and calling tools. And we were around when AutoGPT came out, and that was the same thing, running a loop and calling tools. That didn't really work, but here were 3 agents that were working. So what's the difference? Well, and part of it was the model, but part of it was this harness around the model. And so deep agents is our attempt to kind of like make that a general purpose harness that you can use to create Claude Code for X or Codex for X or something like that. And there's 4 things that were in the initial version of deep agents, and those still hold pretty true today. One was planning. So part of what these harnesses did was have some aspect of planning baked in. We do this in the form of a to-do list tool, which is similar to how Claude Code does it. So the LLM basically generates a list of things and a status for those things and then tracks those over time. But there's no like fixed like splitting up of these tasks. The model just like uses it to track its own work. And it actually turns out this is very helpful for keeping it on track. So planning is one. And this is what the harnesses and the agents are good at. They're good at planning over like longer horizon things. And that's part of where deep comes from. The other part of deep comes from going deep into particular topics. And so subagents are something that are a big part of our deep agent harness and are a big part of Claude Code. And what those do are basically they spin up little agents that are really focused on particular things. And that turns out that has a lot of benefits because you basically give this agent a clear context window and let it do its own thing. And again, that lets it really go deep and go deep into things. That's where the name deep comes from. But it comes back up, it boils back up to this general purpose agent, which is planning and orchestrating these subagents. The third thing that all of these agents had was access to a file system. So all of them, even the research agents, used file systems in various ways, whether it was to write down their plan, whether it's to take notes as over time, whether it's to let the subagent kind of like write notes as little subagents did work and then pass those back to the master agent. And so access to a file system turned out to be a pretty big thing that all of these had in common. And the intuition for why this is important in my mind is it lets the LLM actually manage its own context, because this is where it can dump context to and read context from, basically giving the LLM more control over its environment, including the context that it sees, turns out to be really, really good. And then the fourth thing that we had, which sounds basic, but it's just prompting. I think one thing that people think is sometimes, oh, these models are getting so good, I don't need to prompt it anymore. And that's just not the case. Like if you look at the system prompt for Claude Code, it's like 2,000 lines long if you include kind of like tool definitions. And so even as the models are getting better, a big part of these agents working is them being properly aligned with what you as a human want them to do. And so prompting is still really, really important. And so that was the kind of like core foundations of deep agents when it launched. Those are still the core foundation of it today. I'd say like maybe calling out 2 more things that we think are important for these types of agents. In addition to a file system, access to some sort of like code interpreter or bash tool or something to kind of like run code turns out to be useful for more than just coding agents. It turns out that coding agents are pretty good general purpose agents. And so having this coding ability is really, really flexible. And then the other thing that's really come on recently is this concept of skills. this is different than tools because they're not loaded in up front, and they could contain just like information as opposed to kind of like APIs or something that does something. And it's different than subagents because it's all loaded into the main agent. But the core idea here, again, it goes back to kind of like context engineering. It's just giving the agent a way to load in information at a particular point in time. So rather than hard code everything into one big system prompt, you could have a smaller system prompt and say, hey, this is the core foundation, but if I need to do X, let me read the skill for X. If I need to do Y, let me read the skill for Y. And so we support skills in deep agents. It's now a standard after Anthropic launched it. Most coding agents support it as well. And so I'd say those are like two extra things that have popped up that we've brought into the harness.
Harrison, that's a great explanation of deep agents, right? So really, it's a way for any enterprise company or the developer to essentially build their own version of a Claude Code, OpenClaw, or whatever it is their company wants to build. It has all the elements, the planning, all the context. So for our listeners, can you just walk through the other two packages? It feels like for me, the attention has gone to deep agents, but where does then LangChain sit, which is another package, and then LangGraph?
Yeah. Yeah, so I'll maybe start with LangGraph because that's actually the bottom layer, the fundamental thing that powers all of these. And so, by the way, all of these build on top of each other. So Deep Agents is at the top, and then LangChain is in the middle, and then LangGraph is at the bottom. So what is LangGraph? There's two things LangGraph is. One of it is more like infrastructure than anything else. So we built LangGraph a year after building LangChain. We noticed that there were a lot of basically production infrastructure pieces that we did not build into LangChain from the start because, again, LangChain was a side project, and we didn't know what some of these were at the time either, to be fair. But we noticed there were a bunch of these production infrastructure concerns, such as human-in-the-loop support, durable execution, streaming, persistence, both for kind of like a thread, but also across threads. And so we built this into LangGraph, and we think of it kind of as like an agent runtime. Like no matter how you actually interface with the underlying infrastructure, there is this underlying infrastructure that LangGraph provides. The other part of LangGraph, which people are probably more familiar with or think of it more as, is this agent framework where you define agents as graphs. And that turned out to be really useful because you can basically define any logic that you want as a developer into this graph, and then it's built on top of this infrastructure, so you get this durable execution in between nodes and stuff like that. And so then you can build anything on these graphs. They could be, so again, like LangChain and deep agents are built on top of LangGraph. So you could build these really autonomous systems on top of LangGraph, or you could build these more directed kind of like flows. About a few months ago, we launched LangChain 1.0, and that's now built on top of LangGraph. And what LangChain brings is this kind of like core abstraction of an agent running in a loop and calling tools. And it's really focused on abstractions. And so it really is an agent framework. And when I think of frameworks, I mainly think of the abstractions that they provide. And so LangChain we think of as this agent framework. It's got this core abstraction of the LLM running a loop and calling tools, but it's pretty unopinionated about what happens inside that loop. Or it's very unopinionated, I should say. So it's completely kind of like we provide a bunch of different hooks for you to do a bunch of different things. We do no context engineering for you. The reason, and that's intentional because we want to get in the way as little as possible. We just want to provide nice abstractions. We don't want to provide any context engineering. Deep Agents is built on top. We've already talked about that, but we call that kind of like an agent harness. And we think an agent harness basically has more batteries included. So it does a lot of the context engineering for you, everything that I talked about earlier. And so that's how it's different from LangChain. It's more opinionated about kind of like the right way to do context engineering.
This series is presented by Outshift, Cisco's emerging tech incubation engine and driver of the Internet of Agents, an open, interoperable internet for agent-to-agent collaboration. Learn more about the Internet of Agents and explore how agentic systems are the future at outshift.cisco.com. So actually, Harrison, this would be a good time perhaps for you to talk a little bit about what context engineering is and then unpack perhaps, how is it being done that's different now than say with AutoGPT? Clearly things like Claude Code are pretty amazing at all the different things that it can do. And while you can do all of that with LangGraph or with deep agents, how should people, in enterprise who are looking at sort of building something, how should they approach this?
Yeah, so when I think of context engineering, I basically think of it as bringing the right information in the right format to the LLM at the right time. When agents mess up, they mess up because they don't have the right context. And when they succeed because they have the right context. And specifically, when they have the right context going into each kind of like LLM call. And so that's really all it is. It's a really fancy way of saying like what does the LLM see? And what the LLM sees is different than what you as the developer see. And so it's often helpful to just look exactly at the traces of these agents to see exactly what they're doing and kind of put yourself in their mindset. And so then context engineering just refers to kind of like all the engineering that goes into building systems to bring this context to the agent, to the LLM in that format. And so that includes things like what is the system prompt and how is that created? Is that static or is that populated? What tools does it have? I would consider tools and tool definitions to be part of the prompt. Like you should think very carefully about the descriptions for those, just like you do the prompt. So like what tools does it have? When it makes a tool call and it gets a response back, like how is that presented to the LLM? So when these agents run in a loop and call tools, that's making some assumptions about the context engineering of the agent. Whereas LangGraph and some of the early days of chains and graph-based agents that we saw, there the human engineers would have very opinionated takes about how the context should be structured. There's this part, and this part gets formatted in this way. If this happens and if this other thing happens, then it gets formatted in this other way. And basically, we saw that all of this kind of reduced at the end when the models got good enough to a system prompt that's relatively static. There's pros and cons to this, like site segue. Like if you keep it completely static, then you can take advantage of prompt caching and basically get cheaper calls as you build up more context. But sometimes you actually do want to change things in the system prompt because LLMs respond more to things in the system prompt. So there's just trade-off between kind of like, do I want to invalidate the prompt cache, or do I want to have, or do I want to keep it but maybe lower accuracy? Anyways, like there's the system prompt, and then there's just a list of messages that kind of grow. And then at some point, the list of messages get too long, and you collapse back, and then you grow. And so when we talk about context engineering in the context of like deep agents or Claude Code, that's basically like what's happening under the hood is like what is in the system prompt, and then how does this list of messages grow, and then how does this list of messages get compacted. And AutoGPT had the same style of thing, by the way. Like AutoGPT again was just like running a loop and calling tools. One big difference that I'd say is like I think today's agent harnesses take much more advantage of the file system to do context engineering than AutoGPT did. So I'd need to go back and look, but like I think what happened in AutoGPT, if there was a really big tool call, like imagine you called an API and you got back like 40,000 tokens. I think AutoGPT would just put that as a tool message, and that's what the agent would see. All of the harnesses now dump that to a file because it's too big and say like, hey, here are the first like 1,000 tokens. If you want to read more, you can go use your read file tool to go look this up. And that's basically an example of giving the agent more control over how its context is created. You're basically letting the agent do context engineering for itself. It's deciding whether it should go read that file and bring it into context or not. Taking this idea further, like one of the things that most harnesses don't have, including deep agents right now, but is something we're looking into as the models get better, is like letting the model decide when it wants to collapse its own context. So right now, basically the context grows, and then we have some hard-coded point where we're like, hey, you're gonna, if you add any more context, you're gonna overflow your context window and we're gonna get in model error. So we're gonna force you to collapse. We're gonna do a summarization step. We're gonna force you to collapse. And that's fine, and you probably want to have that as a backup. But in the spirit of giving the model more control, why shouldn't the model just be able to say, hey, I'm done with like part one. Let me like write a little brief to myself and then clear my context and go on to part two. Like, why shouldn't it have that ability? It should have that ability. And so I think that's something that will come in the coming months, probably, to a lot of agent harnesses to give them just more control over their context window. So context engineering is basically deciding what goes into the LLM at a given point in time. And the trend over the past few years in harnesses is to actually give the LLM itself more control over context engineering. Let it decide itself what it sees and what it doesn't see.
Part of that is that file system, or so 2 years ago, nobody would have predicted that the file system would have become such a big deal for agents. If we move forward, what's the next big thing like that, Harrison? Something that will seem obvious in retrospect, but that most enterprises aren't thinking about yet.
I mean, maybe it's already obvious, but I would say code sandboxes. I think it's pretty clear that coding agents are general purpose agents, or at least they can be if prompted kind of like correctly. I think the ability to write code is useful not just for creating code, but it's useful for doing tasks. And so OpenClaw runs in a code sandbox. I think most long-running agents in the future will run in code sandboxes.
Is there a case study or that you could sort of walk us through? It seems to me that we're at this point now where we've got things like OpenClaw, which is kind of pitched as a do-it-all, everything for you kind of agent. And then at the other extreme, we've got super, you know, customized agents for very specific usage, whether that's at Google, whether it's other places. And can you walk us through when you're working with, startups or enterprises, and they're building these agents, what are they actually doing? What's working? What are you seeing that, like, oh yeah, this kind of makes use of the file system? Some sort of real world examples.
Yeah, I mean, when we're working with a lot of these enterprises and customers, basically what they're doing is they're doing context engineering for a very specific task. So Klarna is an example that we've worked with and has made a lot of headlines for all that they're doing with AI. And one of the things that they did was around kind of like customer support. This was a year and a half, 2 years ago. So they actually weren't using deep agents at this point in time, but they were doing kind of like similar. They were doing the things that you would do with deep agents. They were doing context engineering. They were figuring out kind of like what data could come in and what information was needed. And they were doing long running agents as well. So this was actually customer support for kind of like escalation. And I think they reduced customer query resolution time by like 80% and automated like 70% of like repetitive support tasks. And all that was basically writing kind of like custom instructions and writing tools. I think ServiceNow did something similar in kind of like a go-to-market space with customer success workflows. They were basically writing custom instructions and writing tools, and I think this was before deep agents as well. So they were writing kind of like a custom graph or a custom harness. And I'd say like the thing that's kind of changed with deep agents and with these agent harnesses is you don't need to write this custom graph or this custom harness anymore. You use this general purpose harness, but you write custom tools and you write custom instructions. When we work with a bunch of customers, that's what we tell them to spend the most time on. So Cisco is another kind of like example of this. They have a really big customer experience platform, which is built entirely on LangChain, LangGraph, Langsmith, all of our offerings. And a lot of what they do is, again, kind of like figuring out what the right context is, what the right tools are for a particular point in time, and then building an experience where basically the LLMs have access to that context and can do things. And we work with customers in basically every vertical because basically when people work with us, they want to take this general purpose thing and make it really good at a particular thing. If you're doing something general purpose, honestly, the labs are going to do this. That's why the labs kind of like bought or wanted to work with OpenClaw. Like they're going to do general purpose things. But there are a lot of really specific things that customers and enterprises and startups and everyone want to do because it's specific to their data model. It's specific to their workflow. It's specific to their way of doing things. And that's generally when we work with people with LangGraph or LangChain or deep agents or things like that.
Just to sort of finish up on that point, do you think that we're sort of now at the moment where we kind of know what the primitives are, we know what the components are to put all these things together? Like I brought up before, in the early days, I always felt you guys got a lot of flack that was undeserved because you were kind of trying out, skeletons of thoughts, or all these different sort of papers that would come out. And obviously the big ones that like React, which has stayed true to today, but there were a bunch of others that sort of came along, fell down, and stuff like that. But it seemed to me that the cool thing that you guys did was you basically allowed people to try all these things out and sort of see what worked. And it does seem to me now that, like, with the deep agents framework, with what you're sort of just telling us now, you've kind of got the components, right? I guess we haven't touched on memory, but really I'm guessing file storage is the memory, kind of component here. So do you think that these are now sort of, I don't want to say locked in stone, because I know everything will, could flip and change as the models get better or something. But do you think that now we're at a point, sort of 3 years in, of like, okay, we know how to make good agents. It's just now about customizing some of these standard things for specific use cases.
I think there's some things, yes, but other things are still so fast evolving. Like if you just look at like Claude Code, like again, like coding agents are very similar to general purpose agents. If you look at Claude Code's kind of like changelog, they're experimenting with so many different things. They've launched so many things that like at this point like aren't used, or they have so many different commands to do so many different, like there's so many different knobs you can turn. And so no, like I think like it is more, I think like the things that are probably settled and known are like, yeah, let's let the LLM just run in a loop. Let's let it have control over things. Let's not try to control it too much. Let's give it access to an environment, and that environment should probably have a file system and should probably have some coding tools. But then, like, skills versus subagents, and like, should you be able to invoke skills as a subagent? And like, now there's like these multi-swarm things. Like, the concept of harnesses are stable, but the features that harnesses have are not stable. And so like, yeah, I think in a year, like most people when they're building agents will be building with a harness like deep agents or something like that, because there are just like these more known things that are known, and you don't want to be reinventing the wheel for out every time. Um, but we'll be experimenting, and Claude Code is experimenting, and all these harnesses are experimenting with different features to add, and some of them will be hits, and some of them won't be. And yeah, I saw one tweet the other day that is basically like, the harness is the product. Like, the harness is and the things that it do right now. I like, if you look at Manus and Manus's acquisition, like, I think what Manus did really well was they built an amazing harness for interacting, and a lot of what we do in Deep Agents is inspired by things that kind of like they did. And so we want to take a lot of those general purpose learnings and make it so that you don't have to like create like a super amazing harness in order to build an agent. You should be able to use our super amazing harness and then customize it with things that you want. But like, how exactly you customize, and is that skills or subagents or things like that? That unfortunately I think will change a bunch in the next few months.
Very interesting. You touched on just briefly. You touched on long-running agents. So this does seem to be one of the new frontiers, right? The whole idea of having the now that the models are getting good enough that you can have an agent running on a task for perhaps even days, maybe not that too far in the future, weeks. We've seen sort of with Gemini DeepThink, the models are kind of getting agentic in many ways of how they're sort of operating themselves. How do you see those things changing what's going on with the harness and with products?
I think the main way that it will change what's going on with the harness is that the harness needs to be equipped to let the model do things that help keep its coherence over longer tasks. So the harness needs to be amenable to letting the model, like, I mean, even the example I gave earlier of the model deciding when to compact its contexts. That's really useful, because then it can do that at a point that it thinks is advantageous, and it won't lose context, or it will do it in the right way, so that when it goes on to the next step, and it goes on to like step 2 or step 3 or step 4 out of a 200 step thing that it needs to do, like, it has a way to track its progress and keep that coherence. And a lot of that comes down to letting the LLM write its thoughts down as it goes along, essentially. Um, and then how does it affect products? I think the big thing that affects is like the UX of these products. Like, a lot of the UX right now is around chat, but if I kick off a long running thing and it runs for like 2 hours, I don't want to be staring at a chat window, right? I want to like, I think we need to think of a different UX for this. And we have a no code agent builder of our own, and we've been exploring some different UXs there, including kind of like an inbox UX where the agent is triggered either by a human or events in the background. And by the way, events in the background are great for triggering long running events, because if I get an email and I have to go in and tell the agent to respond to the email, I don't want to wait for a while. If this agent's always on and always triggered, I don't care if it takes 30 minutes to do the email, because I'm not looking at my email like every minute, right? I probably go check it a few times a day, and it just needs this list of things for me to look at. And so I think this inbox style of things and triggered by events, these both get at like this overall change that will probably have to happen as agents get longer and longer running in the UX of these applications.
Harrison, for our listeners in the enterprise set, wanted to go a little bit deeper into that stack. You said, the big difference between agents and traditional software is that you just don't know what agents will do until they're in production, right? The inputs are unbounded and the models are spiky. So how does Langsmith address this? And what are the new AI-powered features like the Insights agent and the debug assistant doing for enterprises? Can you touch on those?
Yeah, absolutely. So yeah, one of the things that we've been saying a bunch, and you quoted, is basically, you don't know what your agents are going to do until you run them in production. And the reason for that is that compared to software, these agents, they have a much more infinite kind of like input space. Like, it's natural language. Like, natural language can be anything. If I'm on a SaaS application, there's usually a few buttons for me to click around. Much kind of narrower input space compared to these agents. And then two, these agents are both non-deterministic, and they're really spiky in terms of like, they're sensitive to small changes in the prompt. And so all of this combines to the fact that, like, you write some input, and the agent you're working with really could do anything out there, especially as you give it more control and more tools and more things to do. And so basically what that changes is like, in order to know what your agent's doing, you need to have really good observability into what it actually did on traces. And that's the core kind of like foundation of LangSmith, which is our enterprise platform. The core foundation is traces. It's agent traces. Um, that's a record of everything that the agent did, in what order, exactly what went into each step at each point in time. We talked about context engineering. Step one for improving context engineering is knowing what happened or what the context was at a particular point. And so we provide that. And then these traces empower a bunch of other things. So they empower things like evals. Because so evals are this interesting thing where you basically want to run a bunch of edge cases against the model before it goes into production to ensure that it's behaving in a particular way. What should the edge cases be? You don't actually know that until you ship it to your users and see how they're and see what they're struggling at and see what they're using it on. So we have this flywheel where you can add these traces to a data set and then run them for regression testing and stuff like that. We have a debug mode where you can open up these traces in a playground and mess around with the prompt there and do some experimentation. Just like if I was, you writing Python, I'd have like PDB or some debugger like that. I can do that with our playground thing. And then one of the big things we're thinking about right now is okay, it's great to look at these traces. That's the first thing you can do. But what if you got a million traces? What if you've got an agent that's doing like I spent some time chatting with Clay, who's a Gen AI native up and comer. I don't actually know the exact scale of their agents, but it's millions, if not billions, a month. They can't look at that by eye, right? Like they just don't have enough time to. So this is where we want to bring basically proxies of human intelligence to look at these traces. And what is a proxy for human intelligence? It's an LLM itself. So that's all a fancy way of saying that we'll let an LLM look at these traces and try to see like insights, and those insights depend on what you want to know. Do you want to know how users are using it? Great. You ask it to kind of like classify that and cluster it and stuff like that. Do you want to know if the agent's messing up? Great. You ask it to look for places where the user might be confused or where the agent calls the same tool like 3 times in a row and gets different errors, and or anything like that. So TLDR is, yeah, in order to make these agents reliable, we think observability and traces is really, really important. That's the foundation of LangSmith, and then there's all these cool things you can do on top.
You walked through some examples a while ago, Klarna, ServiceNow. I mean, you're serving some really big companies, Replit, which is one of the more sophisticated agents now and seeing big traction. Cisco, you mentioned Clay. All of these companies are using LangChain and its various offerings. Can you just walk us through what you've learned over the last few months in terms of what you're learning from those customers, like where you're going deeper with them? Are there any other these observations with your customers that you're now rolling into your product and that you're bringing back into your product so you can actually have this, I don't know, maybe a moat for your offering in the enterprise?
Yeah, we do that a lot. So you mentioned Replit. One thing that we learned from Replit, which is very kind of like agenty, is it's very common to have search between traces. But what's less common, and no one I don't think really had it until we added it, which is basically like search within a trace. And that was because Replit's traces were like hundreds, thousands of steps long. And so you'd actually want to find exactly the point in the trace where an agent did something. And so we have kind of like search within a trace. In Insights agents, the feature I mentioned where you can kind of like group and cluster things, that was born out of conversations with customers like Clay that are very high volume, and basically they were saying things like, yeah, we have all this usage, we can't possibly look at it by eye. We when a user yells at us, great, we'll go in and find their trace and look at it, but like other than that, we don't know what's going on. And so like that was absolutely informed by these companies that are in production at high scale, and there's only a few of them out there today. Like and we hope there will be a lot more. But we're lucky enough to work with folks like Clay who help inform that. Um, I mean, there's another digital native, growth stage darling startup that we work with, where one of the things that they really wanted, that they were struggling with, was creating these LLM as a judges. So these LLM as a judges are really useful when you need to look at like these kind of like agent traces, because they're natural language, so you need some LLM to look at it. But the big issue there is getting that to align with human preferences. And so now we have this concept in LangSmith called kind of like align evals, where you label data and then we help turn that into kind of like an LLM as a judge. And so it's basically like data labeling to something that proxies / gets the results for that. And so that's another example where, we're working with companies who need to use LLM as a judge because they're at scale and they're doing complex things. And so we try to think about how we can make that easier and easier.
You mentioned that sort of like agent trajectories are getting longer. How else are they changing? That's one thing I'm really interested in. And the other thing I'm sort of another sort of follow up is, can all this be eventually automated? Clearly, prompt engineering has been a thing, right? Even today, getting the right system prompt clearly has a massive advantage. But with things like Langsmith, with the agents sort of looking at these trajectories. This is sort of even going beyond evals in a way. That how much can this actually be automated?
How have trajectories changed? They've consistently gotten longer. We did something. We released. This is about a year old. We need to re up the stats, but we released something about kind of like the length of trajectories over time. And I think they like doubled or tripled throughout 2024. This was like a 2024 retrospective, so we don't have super up to date numbers, but like they're increasing. Why are they increasing? Mainly because it's doing more tool calls. So we're seeing the number of tool calls that happen increase. One of the things that we're also seeing as these agents take more action, there's more like human in the loop things. So one of the things we have a concept of in Langsmith is threads. So the difference between a trace and a thread is that a thread is basically like multiple traces stacked up, and a trace ends when a human gets involved. So this could be like a chat conversation, but this also could be like the human like approving things. If you use Claude Code, for example, you have to approve it before it runs a command in your terminal or stuff like that. And so we see like that these threads are becoming way more important because agents are doing things and this human in the loop step happens. And so you need to kind of like combine them. I'd say like another way that these trajectories are changing is that we see that as these agents are able to do longer horizon things, that requires kind of like these planning steps up front almost. And so whether it's kind of like internet research or research over a code base, oftentimes these trajectories now have the start of the trajectories is often the LLM just exploring the code base or internet search or something like that, as opposed to jumping in and taking a tool call. Like the first example of agents in LangChain was like, what is the weather in SF? And it would like, call the weather tool first. And like those aren't the simple types of questions that most agents get asked. And so there's oftentimes these like research or planning steps up front, and you see those reflected in the tools calls that it makes. What was the second part of the question?
What about the automation going forward?
Yes, the automation going forward. Yeah, so that's really interesting. So we are releasing a blog probably tomorrow on how we did harness engineering to basically climb up terminal bench 2, which is a benchmark for coding agents. And the main way that we actually did this was we ran the agent, and then we ran another agent which took Langsmith traces and pulled those down and passed it to a coding agent and asked it to look at these Langsmith traces and make improvements based on what was going wrong in the traces. And so essentially we were doing some of this in an automated fashion. There was still a human in the loop. So specifically what they would do is they would be like, hey, here are 10 traces, go look at them and suggest some changes to make. And then the human in the loop would say, yeah, that's a good idea, or no, that's good, a bad idea. But there's some automation there of this flywheel. This also kind of gets into memory. I think memory and like prompt optimization are basically the same thing. It's taking feedback in some form and updating the prompt in some form. And yeah, memory we're starting to see more and more be more and more viable as companies are using it. It's usually reacting to feedback that's like in a conversation, like, oh no, you should have done this instead of this. And so then it takes a note and remembers that. But yeah, this type of like meta thinking about what it should have done starting to become more viable. It's still not absolutely still not perfect. And so it kind of depends on the starting point of where you're at. If you're at a pretty basic starting point, things like if you try to do automated prompt engineering or something like that, it can probably work. If you've got a really complex prompt, it's probably going to be more useful for kind of like brainstorming than anything else.
Harrison, you mentioned memory as being part of the file system, but for our enterprise listeners, can you talk a little bit about? I think you mentioned that your post on memory was one of the most viewed on Twitter recently. Can you talk a little bit about the different forms of memory and this idea that I think a lot of the enterprise users are going to be a little concerned about the context that they're providing to these LLMs, concerned around how much they're releasing some of that intelligence. They like to keep some of that memory, right, internal. Can you talk a little about the different kinds and where memory is going?
a few thoughts here. First, on kind of like the memory itself and kind of like keeping that internal. I think like absolutely enterprises want to keep that internal, but I also think importantly, like they want control over their memory, and so I think there's two different versions of memory that could happen. One is basically like the knowledge going into the weights of the model, and the other is the knowledge sitting outside the weights of the model and getting pulled in through context, basically. I think the latter is far more kind of like auditable for sure, gives you full ownership over that data as well, and makes it portable between models. Basically, we see memory being represented as a set of files that gets pulled in specific ways. How does it get pulled in? I've learned a lot about human psychology through thinking about memory, far more than I ever knew before. There's three different types of memory in humans: procedural, semantic, and episodic. What are these? Procedural is how to do things. Semantic is like random facts. And episodic is specific kind of like things that actually happened. How does this map on to kind of like memory for agents? Procedural can be thought of as like the system prompt or the skills that it has, like how to do particular things. Semantic is kind of like, you think of semantic search, that's exactly it. It's kind of like doing retrieval over some corpus to get back some information. And then episodic is basically previous things that the agent done. So previous threads, previous chats. In practice, the ways that we see people exposing these to agents, again, procedural is basically like the agent.md or skills. The agent just modifies those files. Like that's how it updates those. It just decides that hey, like the user said something that conflicts with some of my instructions. Let me update the instructions. Semantic, it populates some database. This is actually the one we see being done the least. And so probably, a little bit more speculative here, but it does that by basically running over previous conversations and extracting facts and putting them into some sort of data structure, whether it be a vector database or a graph or something like that. Episodic's quite simple. You basically just give it a tool where it can search its previous messages or list its previous conversations or things like that. I personally think for enterprises that the procedural stuff is the biggest bang for the buck. Oftentimes we see that agents are being built to do a particular task. And so what you want the agent to remember is how to do that task the best, not necessarily what my favorite color is. And so that's where procedural memory, I think, becomes really, really useful.
All the LLM companies have tried to do agents. A lot of other big companies and even harness companies like yourself have tried to sort of make them a lot of these sorts of agents. Yet it turns out the one that got the most traction, or it certainly seems like one of the ones that got the most traction, OpenClaw, came out of left field, even though it had all the deep agents thing that you talked about and stuff like that. What's your take on that?
I think a lot of things in the space are basically about catching lightning in a bottle. And I think if you look at everything that succeeded, like that happened to LangChain, that happened to ChatGPT, that happened to Claude Code, that happened to AutoGPT, that happened to OpenClaw, right? It's all kind of like catching lightning in a bottle. There are a bunch of projects very similar to OpenClaw. They didn't catch lightning in a bottle for whatever reason, and then it's too late. Like I think there's only one that often catches lightning in a bottle. Google and Anthropic are trying very hard to catch up to ChatGPT, for example, but like ChatGPT is still king. They caught lightning in a bottle. And early days of LangChain were me just building the library and tweeting about it. And I think that's what ClaudeBot did back in the day. It was, it was just Peter kind of like building it and tweeting about it. Everyone on AI is on Twitter, it seems. And so if you just launch cool stuff and talk about it on Twitter, people will see and take notice. And that's a major kind of like distribution kind of like channel. Like I would actually say Claude Code is an example of an agent that took off before OpenClaw that honestly probably has more like practical value. I think OpenClaw clearly did a very, very good job of kind of like pushing the boundaries of what you could do, and exposing it to a new set of users and giving it like way more connections and way more autonomy. I think that's probably something that Anthropic wasn't going to do because I think they're probably a little bit more careful about or a little bit more hedged about what they released, a little bit more guarded about what they release. So I think OpenClaw was really about just giving it, like letting it rip to the full max. But I think I think OpenAI, when they talked about early on why they, are giving API access to these models and stuff like that, like, oh, if this thing's like so powerful, why are we letting people access it over the API? It's because there is like so much you can do with it, and to some extent we kind of need these random hackers like myself and like Peter and like Toron, who built AutoGPT, just like go try things and see what happens. And I think that's part of the fun of building in the space is like there's so many wacky ideas of what you could do. OpenAI is never going to come up with all of them. Anthropic's never going to come up with all of them. Even if they do, like, these experiments are going to pale in comparison to, like, Claude Code or something like that and at the start. And then obviously they bloom into big things, but that's only because, Peter had a really, really good idea and just kept on doing it for a bunch of months and kept on tweeting about it and made a really good product. And anyone can kind of do that. It's so early on. Like, anyone can do that.
Do you think it's a strategic move on OpenAI's part to sort of acquire him and perhaps sort of the project? And also, do you think it's like a reflection on that they've had multiple sort of shots at trying to make these agents in ChatGPT, which haven't really taken off? And does that sort of show that maybe the UI and UX here is actually more important than some of the once you've got the low level parts of the agent, it becomes all about the UI and UX, is what I'm saying.
I think it's more like OpenClaw is just like unhinged. Like, and I say that in a loving way, but like, we told our employees they cannot install OpenClaw on their laptop, on their company laptops. Like, there's just massive kind of like security risk, and like OpenAI is never going to release anything like that. They can't release anything like that, right? Like, they're not going to put that in ChatGPT. But like, that's what makes OpenClaw OpenClaw. And so if you don't do that, you also can't have an OpenClaw. And so I think I think that's why it kind of has to come from hackers, these types of like boundary pushing things. Like, I don't think those are big things that like labs can roll out to billions of people. I do think those are things that hackers can do as open source projects. I'm interested to see what happens with it. Like, I think it's pretty clear to most people, like, a version of OpenClaw is like a good idea. Like, I think you see Manus is rolling out with Meta, things like this. I think you see like Kimmy rolled out like some OpenClaw thing. I do think that like Claude Cowork is not that different from OpenClaw. It's like more locked down. It's like less connected. But like, again, those connections are things that you can only really do if you're kind of like a hack. Like, what is the safe enterprise version of OpenClaw? I think I actually don't know who's closer to that. Is it Claude Cowork or is it actually OpenClaw? I think it is strategic in that it's a massively popular open source project. I think a lot of people right now are working on like the safe/enterprise version of OpenClaw, and I'm very interested to see what that ends up looking like. And I don't know if like acquiring the project actually gets you that much of a step up in that direction.
Well, one of the things that the founder, Peter Steinberger, has referred to when he explains the project is to focus on simplicity, right? And it's almost like the exact opposite of LangChain, where you have all this depth and richness, right? It's heavy, right? There's a lot of libraries and in parts of the framework, obviously a lot of offerings. Stepping back, it's a simplification, right? This meta approach. Okay, I'm going to have an agent that's able to do everything for me. A lot of risks, obviously. I'm curious, if as Sam mentioned, if it's the UI UX kind of winning over the tech in some ways, is there anything that you're taking from this and rolling into your roadmap going forward?
Yeah, coding agents or general purpose agents. Like, I think the reason that it's able to have such a simple UX is because under the hood it can write code for itself that the user never needs to see. But like, that's what gives it a lot of the abilities. I think that's absolutely kind of like part of that. That's probably the biggest takeaway of what we're taking going forward. We do have our first like no code product, which is Langsmith Agent Builder, that is aimed kind of like at a similar audience. With all the coding agents, we've seen that people saying like English is the new coding language or something like that. It's just natural language. English is maybe like the new, and I say English not meaning like whatever language you speak, but like English is the new like just building language. I think when people use OpenClaw, they think almost they're basically like building a personal assistant for themselves, even if they don't realize it, maybe. And that's actually part of the genius of it. They don't realize that they're building something because they're just interacting with it. So memory, so that would actually be another technical takeaway. Memory is really important because it helps you like build something without realizing that you're building something. Natural language as the simple input, memory, and coding are maybe like three things that I take away from it.
I'm curious if, as you take a step back and you think through this amazing set of events that have been happening over the last few months, and as you go deeper and you're making all these new offerings, you've got the agent builder, as you said, you've got deep agents, so you're staying up with the pack. You've got this really great thing in Langsmith. Um, where would you say your key moat is? Is it in the harness? Is it in the evals and observability? Where do you become lodged in kind of the mental framework of the enterprise technical decision maker at the end of the day?
I think it's in the observability. I think it's in the observability, which powers a lot of stuff. It powers evals, it powers annotation queues, it powers this debugging stuff. We built LangSmith so that you could use it with our deep agents harness, or you could use it without. You could use it with no harness. You could use it with your own. You could use it with Claude Agent SDK. And so I think our kind of like foundation really is this observability, which we think powers all of these different actions, and we want to integrate into all of the harnesses out there. And building deep agents, it keeps us close to what people are building so that we can build features that are useful for the cutting edge into LangSmith that will, the gap between cutting edge and, what the, average enterprise developer wants to do. That's actually not that large these days because the space is moving so fast. And yes, like OpenClaw is cutting edge, but I guarantee that every enterprise developer out there wants to put a safe version of OpenClaw onto like their computer or expose it to their users. And so like we use deep agents and agent harnesses as a way to keep up to date with all of that and figure out what is needed for observability and evals in the foundation. But we think that just like traces and observability are so core to getting an agent that actually works. And so that's where we're really focused.
Harrison, it's been a fantastic conversation. Very fascinating hearing your take on a lot of different things. Thank you very much for your time.
Thank you guys for having me. It was really fun.
Thanks, Harrison.
And special thanks to our presenting sponsor, Outshift by Cisco. You can learn more about their work on the Internet of Agents via their Linux Foundation project, agntcy.org. This open source project enables agents to work at scale across any vendor or framework with trusted and secure discovery, identity access, and observability. For more stories about the AI revolution, like and subscribe to the podcast and check out VentureBeat.com to sign up for our newsletters.